What is DNS Server? The domain name system, DNS, is a distributed hierarchical system that allows computers and other devices to find and connect to other devices on the internet. A DNS server is a specialized computer that helps manage the DNS system, translating human-readable domain names into numerical IP addresses that can be used to connect to devices on the internet. When you type a web address into your web browser, the browser sends a request to a DNS server to translate the domain name into an IP address. The DNS server then looks up the IP address associated with the domain name and returns it to the browser. This allows the browser to connect to the device associated with the IP address, such as a web server that hosts the website you are trying to access. DNS servers work by storing and maintaining a large database of domain names and their associated IP addresses. When a DNS server receives a request to translate a domain name into an IP address, it searches its database to find the appropriate IP address. If it doesn't have the IP address stored in its database, it forwards the request to other DNS servers higher up in the hierarchy until it finds a server that has the information it needs. The DNS system is hierarchical, with the root domain at the top of the hierarchy. The root domain contains information about the top-level domains, TLDs, such as .com, .org, .net, and country-specific TLDs such as UK or FR. Each TLD is managed by a separate organization, which in turn manages the domain names within that TLD. For example, VeriSign manages the .com TLD, while the Public Interest Registry manages the .org TLD. There are several types of DNS servers, each with its own specific function. The most common types are authoritative DNS servers, recursive DNS servers, and caching DNS servers. Authoritative DNS servers are responsible for storing and managing the DNS records for a specific domain. When a DNS server receives a request for a domain name associated with a specific authoritative DNS server, it can provide the IP address directly without having to search for it elsewhere. Recursive DNS servers are responsible for handling requests from client devices to resolve domain names. They search the DNS hierarchy for the IP address associated with the domain name, starting at the root domain and working their way down the hierarchy until they find the appropriate IP address. Caching DNS servers are used to store recently accessed DNS records in memory, so that they can be quickly accessed without having to be looked up again. This helps reduce the load on the DNS system, making it faster and more efficient. DNS servers are critical to the functioning of the internet, as they provide the backbone for the way devices connect and communicate with each other. Without DNS servers, it would be difficult for users to find and connect to the devices they need on the internet. DNS servers are also a key target for hackers and cybercriminals, who may try to exploit vulnerabilities in the system to launch attacks on websites and other online services. To prevent such attacks, DNS servers may use various security measures, such as using encryption to protect the data being transmitted between servers, and implementing measures to prevent unauthorized access and modification of DNS records. DNS servers may also use load balancing techniques to distribute traffic across multiple servers, ensuring that the system can handle large volumes of requests without becoming overloaded. In summary, DNS servers are specialized computers that play a critical role in the functioning of the internet. They translate human-readable domain names into numerical IP addresses that devices can use to connect to each other. The DNS system is hierarchical, with a root domain at the top of the hierarchy and TLDs managed by separate organizations. There are several types of DNS servers, each with its own specific function. To ensure the security and stability of the system, DNS servers may use various security measures and load balancing techniques to prevent overloading. While DNS servers are generally reliable, they can experience problems that can disrupt the normal functioning of the internet. For example, a DNS server may experience a distributed denial of service (DDoS) attack, which floods the server with traffic and makes it unavailable. To prevent such problems, DNS servers often have redundant backups, which can take over if the primary server becomes unavailable. DNS servers are also important for businesses, as they allow businesses to host their own websites and email servers, and provide access to their internal networks. A business can use its own DNS server to manage the domain names for its website and email servers, as well as to manage the domain names of its internal networks. This can help the business to ensure that its website and email servers are accessible to its customers and employees, and that its internal networks are secure and protected from unauthorized access. In addition, DNS servers can be used for other purposes, such as content filtering and parental controls. DNS servers can be configured to block access to specific websites or content, making them useful for organizations that want to control the websites that their employees or students can access. DNS servers can also be used to implement parental controls, allowing parents to block access to inappropriate content on their children's devices. Overall, DNS servers are a critical component of the Internet, allowing devices to find and connect to each other using human-readable domain names. They are responsible for translating domain names into numerical IP addresses, and are a key target for hackers and cybercriminals. DNS servers use various security measures and load balancing techniques to prevent overloading and ensure the stability of the system. They are also important for businesses, allowing them to host their own websites and email servers, and provide access to their internal networks. DNS servers can also be used for other purposes, such as content filtering and parental controls, making them a versatile tool for managing online access and security.